Hello, we're here at Class 1 Equipment. Today is June 9th, 2015, and this is the proof of life video for ID 4011, which is an Oxford Plasmalab 800 plus PECVD. System's been fully refurbished and it's running well now. So the first thing I'd like to show you is let's open up the chamber. Set the hoist switch to chamber up and press both hoist buttons. Okay, here you can see the platen, which has been expanded. The pocket has been expanded to accommodate 300 by 300 millimeter square substrates. We've got the shower head. Close it back up. Okay, move over to the system computer. Let's do a pump down. We're in the pump control screen now, found at System Pumping. And here you can see the user interface with the chamber, the 4-line, the slow pump line, the blower, and the pump. To pump down, you can pump down very quickly if you hit evacuate, or you can pump down a little slower by giving some soft pump time. So let's give 45 seconds of soft pump time and hit evacuate. The system's asking if we inserted a wafer. Let's pretend we did and call it test. That's our wafer name. See the icon for a wafer appeared. We've started counting 45 seconds worth of slow pump time. Now met the 600 millibar gas pod interlock threshold. About 10 more seconds, we'll go into fast pumping mode. Valves opened up, throttle valve opens. We've come off our 2 torr manometer, and we're pumping to base. Okay, let's take a quick tour around to the system components. Obviously, monitor, mouse, keyboard, system PC. Here you've got the main chamber. Behind the front door, you have the system on-off buttons, the slow pump speed control dial. You've got the match network controls, Honeywell temperature controller, low frequency transformer, and low frequency power supply. The high frequency power supply is behind this cover. The system comes with this Plasmalab HX75 chiller. Chiller has the optional heater module. You can see we're controlling temperature to 40 degrees right now. To set temperature, you hold down the display button, and then the adjustment knob can be changed to whatever set point you want. So you can see it's controlling nicely to 40. Behind that, we have the system pump. Pumps an Alcatel ADS 602 pump. Has top-mounted facilities. Here's the rear of the system. Gate valve, throttle valve. System facilities inputs. Behind this panel, here's the main input and the local power box. Over here we have the 6-channel gas box and its stand. This gas box also has been refurbished, all new pneumatic lines, new cables, a couple new gas sticks. Set for 6 gases with 2 clean gases. Currently we're only plumbed running nitrogen. Pump connections, power for the pump comes directly from the tool. Pump exhaust. Okay, let's go ahead and run a couple runs. I've made some short test runs for this video. First, let's go to the process chamber view. This shows the recipe data, name, step time, how often log files are generated, system pressure, current pressure, and set point pressure, table temperature, APC controller. You can use a set pressure or a set position. Here you've got the gas box, set points on the right, actuals at the MFC, and the generators. You have high and low freak power applied both to the shower head. These generators can be run one individually, they can be run at the same time, or they can be pulsed between the two of them. I'll show you an example of that. You notice you can't see any clean gas set points right now. That's because we're not in the clean gas mode. Now if we go to the recipe screen, you select between chamber recipes and cleaning recipes. So our first run, let's run a clean recipe. I'll hit load, and here's my list of recipes. Obviously it's a little short. Select clean test. Now the steps of this recipe are displayed. I have an O2 only step, a CF4 step, O2 plus CF4 at 700 millitorr step, and a 200 watts of RF. Let's go ahead and run that. Pops up a warning. It thinks we have a wafer in the chamber. We don't actually, so I'll just say yes, I'm sure I want to start. It popped us back to the process view. Here's the recipe name, clean test. Temperature. You see we met all tolerances, so step 1 started. It's very short, just showing O2 flowing alone. No pressure control. Alright, next step, CF4 only. So that flows right as well. Next step, flows both O2 and CF4 in proportion. Here's your actual flows. This one's a little bit off. We're just running nitrogen right now, so the correction factor isn't right. You see pressure control now. Throttle valve is closing down. It's at 27 degrees to achieve 700 millitorr. Once it achieves 700 millitorr, the process starts this recipe, and we start counting down our 45 seconds. Okay, our next step is going to put high frequency power. Once pressure builds back up. Okay, the APC is close, so if you look at the top it says stabilization time is counting down. Stabilization's done and the process has started. We're applying 200 watts forward power, 1 watt reflected. You can see the high frequency is on. Plasma in the chamber. Okay, that's the end of this recipe. End of processed reach, I'll accept that. Okay, next we're going to run just a standard process recipe. Click on process recipes. I want to change to a chamber recipe. There's nothing loaded currently, so load my test recipe. Basically it's just flowing nitrogen and then running a pulsed RF. Okay, so step 1, we're stabilizing pressure to 1.2 torr, 400 SCCM of nitrogen. Okay, pressure's in range now. Counting down the stabilization time, and then step starts. During refurbishment of the system pump is sent out for rebuild. All the MFCs are sent out for clean and calibrate. System chiller is serviced. Inside the chamber, all the seals are changed. 4-line, pumping line, everything's taken apart, re-cleaned, new seals installed. Then we troubleshoot for any problems, repair as needed. Okay, here comes our pulsed plasma step. Pressure will stabilize, same gas flow, same pressure control. This time with high frequency we'll turn on first for 15 seconds, and then we'll have 15 seconds of low frequency, and then it'll just hop back and forth. High frequency, here comes low frequency. On the low frequency, the only thing displayed is reflected power. So if you want to see forward power, you have to go look at generator, but I think the step is about to end. Okay, steps over. You can see the system plasma. There's the low frequency. Three, 2, 1, high frequency. Okay. Thanks for watching. This has been Class 1 Equipment's Proof of Life video for ID 4011, an Oxford Plasmalab 800 PECVD system. Thank you very much.